In this video, we're going to discuss how to calculate out the equilibrium concentrations if you have a mix of products and reactants to start with. Previously, we've seen situations where we put in just starting material and no products, and so we knew we had to go to products. So we had to lose some starting material and create products. The direction the reaction would go would be obvious due to the lack of any material on one side of the equation. However, what happens if you have a mix on both sides of the equation? Let's say I had initial concentrations in 1 liter, and so these are the moles in that liter. We had 0.07 molar PCl3, we had 1.2 molar Cl2, and we had 0.3 molar PCl5. Well, the first thing we need to do is we need to identify which direction this reaction is going to proceed. It changes how my change component will go. Which gets minus x, which gets plus x. If I'm moving towards products, I'm going to increase my products and reduce my reagents. But if I'm moving towards my reagents, towards the starting materials side, the left, then I'm going to increase the starting materials and I'm going to decrease the product. For this, I need to solve Q. What is my present quotient? I can compare that to my equilibrium value to determine which direction this reaction will go. That's going to be PCl5 divided by PCl3 and Cl2. 0.3, 0.07, 1.2. If we actually calculate out our Q at this moment, it is 3.57. Q is greater than KEQ, than our KC up above. Well, why do I have a greater value when I do this division? Well, my top is too large and or my bottom is too small. When you do division to get a larger answer out, you need more on top or less on bottom. So at the moment, I have too much product and not enough reactant. At equilibrium, I should have a much smaller value when I do the division, which means I need less on top and more on bottom. So I am going towards reactants, which means I'm going to lose some starting material and I'm going to gain reactants. So when we started with the mixture, first step we needed to do was identify the direction of the reaction so we knew what the changes were going to be, which was going to be plus and which was going to be minus. They're all 1-to-1, so it's all x for their change, which means at equilibrium, we'll have 0.07 plus the amount of starting material gained, 1.2 plus x, and 0.3 minus x. We'll have lost some products. We can still set this up equal to our K value, so 0.18, our equilibrium value, must equal these equilibrium concentrations. Our product, 0.3 minus x. Our reactants, 0.07 plus x times 1.2 plus x. This will give us 0.3 minus x still on top. X squared plus 1.27x plus 0.084 on bottom. Multiply that whole part up times 0.18 to rearrange. 0.18x squared plus 0.2286x plus 0.01512 must equal 0.3 minus x. Now we're setting up the quadratic. Could we have made a simplifying assumption? Well, k is reasonably close to 1, and all our other values are reasonably close to 1, all within a power of it. Unlikely that when I divide any of these by k, I get something greater than 400 for its ratio. So really, we could not do the simplifying assumption. All of these values were going to change rather significantly from their original value. And so I do need to go through the quadratic for this. I'll need to add x, I'll need to subtract 0.3 from both sides. We'll find that 0 is equal to 0.18x squared plus 1.2286x minus 0.28488. Our quadratic is going to give us a plus and a minus option, which will be 0.22449, and a subtraction option, which will be negative 7.05005. Which one of these makes logical sense? Well, I don't think I can subtract negative 7 or add negative 7 to any of these. So it must be the addition route 0.225, which I can subtract from 0.3 and easily add to the others. Which means our equilibrium concentration is going to be 0.07551 for our product, 1.42449 for Cl2, and 0.29449 for PCl3. Plug those in and check real quick. 0.7551 divided by 0.29449 times 1.42449 is all equal to 0.18. So we can find what our concentrations at equilibrium are going to change to. Our original 0.3 molar PCl5 has decreased to 0.08. Our Cl2 has gone from 1.2 up to 1.4 some, and PCl3 has increased from 0.07 to almost 0.3. Well, the quadratic can be a little bit more complex in terms of its A, B, and C values when we have concentrations on both sides. Our ability to calculate out what that equilibrium is going to be is nonetheless the same. I simply need to identify which direction the reaction is going to go to apply the appropriate plus and minus to the change, find what an equilibrium value is going to look like, plug it into the mass action expression, reorganize to form the quadratic, and then solve for the plus and the minus options. Choose the one that makes chemical sense. Plug that back in to find your equilibrium concentrations.